This is the budding light of hope and knowledge, the delight of Sri Prakash educational institutions, spreading academic brilliance in all directions.
Welcome to Sri Prakash Educational Institution's online video content. In today's session, we are discussing 9th standard, a physics topic, graphical representation of motion, second volume from motion chapter, and myself, T. Vinod. Instructions to be followed. Be ready with your textbook, notebook, and pen. Watch and listen to the video carefully. Jot down all the important points in your notebook. In today's agenda, we will learn the word of the day, recite the previous knowledge, learn how to plot distance time graph, velocity time graphs, and then calculate the speed, distance covered, and acceleration from the graphs, and summarize at the end of what we have learned from this module. Word of the day, representation. It's a noun, meaning the act of presenting somebody something in a particular way. Conjugation, represent, represents, representing, represented. Usage, the farmers demanded greater representation in the parliament. The learning outcomes of this module, the students will be able to understand the graphical representation of motion, identify the type of motion by visualizing the graphical representation. Students will learn to plot distance time graphs and velocity time graphs. They also learn to calculate speed, velocity, distance traveled, displacement, acceleration from the graphs. Graph. We are well aware with different types of graphs, the line graph, the bar graph, the pie chart. When a set of data measurements is presented on a graph paper, it is called a graph. What is the advantage of graph? Graphs are very attractive and effective means of presenting data. Even the most complex information is made simple and understandable with the help of graph, isn't it? Just by having a glance at the graph, we can easily understand the information conveyed in a detailed manner from the graph. Graphs facilitate a comparative glance at the data. We can analyze the data from the graph. These are some of the advantages of the graphs. Distance time graph. Time is always taken along x-axis. We plot independent variables on x-axis. Those variables for which we have the freedom to break at regular intervals, we plot them on x-axis and are called independent variables. Distance is taken along y-axis, which is a dependent variable. Distance time graph. Case 1. Body moving with a uniform speed. So we will plot a graph of the body which is moving with uniform speed. Looking at the data which is given here in the table, at time interval 0 seconds, the distance traveled is 0. So our point will be at the origin. For 5 seconds, the distance covered is 10 meters. For 10 seconds, the distance covered is 20 meters. For 15 seconds, the distance covered is 30 meters. For 20 seconds, the distance covered is 40 meters. And for 25 seconds, the distance covered is 50 meters. Now, the graph will be a straight line for a body moving with uniform speed. Distance time graph. Nature of the graph for uniform speed or uniform motion. It is a straight line having a constant slope with the time axis. Here we have taken time along the x-axis. So you can see from the graph it is a straight line having a slope with the time axis. Calculating the speed from distance time graph. From the above example, we will find the speed between two time intervals t1 at 15 seconds and the distance represented along the y-axis with s1 and the t2 time interval at 25 seconds represented, and then we have the distance along y-axis is 50 meters. The time between the two time intervals is t2 minus t1 along the x-axis, and the distance between the two intervals is s2 minus s1. We know that speed is equal to distance by time. From the graph, distance is represented by s2 minus s1 along the y-axis, and the time is represented by t2 minus t1 along the x-axis. So this is going to change like this. Speed is equal to change in y-axis by change in x-axis. But this formula represents the slope of the graph. In order to find the slope of the graph, we will compare the change in y-axis with respect to the change in the x-axis. So finding the speed from the distance time graph is equal to finding the slope of the distance time graph. The slope of distance time graph is equal to the magnitude of the speed of the moving body. To find the speed of a moving body, we calculate the slope of the distance time graph. Case 2. Body moving with non-uniform speed. From the data, we will plot the graph. For 0 seconds, the distance traveled is 0 meters. So it will be at the origin. For 5 seconds, the distance traveled is 20 meters. For 10 seconds, the distance traveled is 30 meters. For 15 seconds, the distance traveled is 50 meters. For 20 seconds, the distance traveled is 55 meters. For 25 seconds, the distance traveled is 60 meters. The graph will be a line which is a curve and not a straight. Nature of the graph of a body moving with non-uniform speed. Distance time graph of a body moving at non-uniform speed is not a straight line but a curved line. Distance time graph of a body at rest. Case 3. Looking at the data, for the time 0 seconds, the distance from the origin is 30 meters. For 5 seconds, the distance is 30 meters. For 10 seconds, it is 30 meters. The position remains stationary. So it is 30 meters as the time is ticking. For 20 seconds, the distance is 30 meters. And for 25 seconds, the position is same at 30 meters. So the result of this graph will be a straight line but parallel to time axis. Nature of the graph of a body at rest. The distance time graph of a body at rest is a straight line parallel to the x-axis, which is the time axis. By now, we have successfully completed the distance time graph. Now, we will learn the velocity time graphs. From the graph, it is clear that time is represented on the x-axis and velocity along the y-axis. Time, being an independent variable, is taken along x-axis, and velocity, as it is a dependent variable, it is taken along the y-axis. Case 1. Body moving with constant velocity. We are representing a body moving with constant velocity on velocity time graph. So from the data, the body is moving with a uniform velocity of 40 km per hour for every hour. So when the time is at 0, initially the body has already started moving with 40 km per hour. For 1 hour it is 40 km per hour, and the next hour it is 40 km per hour, and the third hour 40 km per hour, fourth hour, fifth hour, the velocity remains constant at 40 km per hour. So you get a straight line which is parallel to the time axis. Nature of the graph of a body moving with constant velocity. Velocity time graph of a body moving with constant velocity is a straight line parallel to x-axis, which is representing the time. Determination of distance traveled. Finding the distance from the velocity time graph. Considering the example of the velocity time graph of a body moving with uniform velocity 40 km per hour, we take two time intervals t1 and t2 at 3 hours and 5 hours. We try to find the distance traveled between these 2 hours. On the y-axis, the velocity is represented 40 km per hour, which is a constant velocity. So the distance from the formula, we have distance is equal to speed multiplied with time. That is 40 km per hour multiplied time, which is 3 minus 2, t2 minus t1, 40 multiplied with 2, which is 80 kilometer. From the graph, speed is represented by this value, which is the length of the rectangle along the y-axis, and the time is represented by this value, which is the breadth of the rectangle. So if I mark these rectangle A, B, C, D, then the area which is in the blue color region will give us the distance traveled in that time interval. Determination of distance traveled. Magnitude of displacement. The distance traveled or magnitude of displacement is equal to the area enclosed by the velocity time graph and the time axis. Case 2. Velocity time graph of a body starting from rest and accelerates uniformly. We will try to plot from the data that is given. On time axis it is 0 and velocity is 0 meter per second. So we have the point at the origin. For 5 seconds it is 10 meter per second. For 10 seconds the velocity is 20 meter per second. 15 seconds the velocity is 30 meter per second, and for 20 seconds the velocity is 40 meter per second, and for 25 seconds the velocity is 50 meter per second. So the graph will be a straight line having a slope with the time axis. Nature of the graph of a body moving with uniform acceleration. It is a straight line making a constant slope with the time axis. Determination of distance traveled, magnitude of displacement in the case if the body is accelerating uniformly. Now we will take the previous example of the body in uniform acceleration. From the graph, we can find the distance traveled by finding the area enclosed under the graph. So here the graph represents a triangle. We need to find the area of this right triangle ABC. So distance will be equal to the area of triangle ABC. The formula for finding the area of right triangle is half base into height. Here AB represents the base and height is represented by BC, which is half. AB is 25 on the x-axis, 0 to 25, and BC is from 0 to 50. So 50 BC value is 50 along the y-axis. Now we can cancel this half and 50. 2 goes 25 times. 25 multiplied with 25. We will have the answer 625 meter. So we have calculated the distance traveled for a uniformly accelerated motion by finding the area of the triangle. Case 3. Body not initially at rest and accelerates uniformly. So it's a velocity time graph of a body which is not starting at rest but has some initial velocity and accelerates uniformly. Now, from the data here, we can see that at 0 seconds, the body is already moving with 10 meter per second. So the velocity for 0 seconds is represented as 10 meter per second on the y-axis. For 5 seconds it is 20 meter per second, and for 10 seconds it is 30 meter per second, and for 15 seconds it is 40 meter per second, and for 20 seconds it is 50 meter per second, and for 25 seconds it is 60 meter per second. This is the graph for a body which is not initially at rest but uniformly accelerating. Determination of distance traveled. This case is a body which is initially not at rest and accelerating uniformly. In such a case, we can find the distance traveled by finding the area under the graph. To reduce the complications, we can simply divide the area into two geometrical shapes, a rectangle and a triangle. Let us mark the vertices of the rectangle as A, B, C and D, the triangle BCE. By finding the area of the rectangle and by finding the area of triangle and adding them, we can get the total distance traveled in a given time interval by that particular body. The previous example can also be solved in finding the area that is enclosed under the velocity time graph as a single geometric shape, the shape of a trapezium. The vertices of the trapezium are A, B, C, D as marked here. We can find the area of the trapezium ABCD. The formula for finding the area of trapezium is half multiplied with the sum of the parallel sides multiplied with the perpendicular distance between the two parallel sides. Determination of acceleration of the body. Since it is a uniformly accelerated motion, we can find the acceleration of the body between any two time intervals. T1 at 10 seconds, V1 on the y-axis is represented as 30 meter per second, and T2 along x-axis 20 seconds, and V2 is 50 meter per second. Now we can find the time by finding T2 minus T1, and velocity can be represented along the y-axis with V2 minus V1. From the formula of acceleration, acceleration is given by the change in velocity divided by the time taken. From the graph, it is clear that v2 minus v1 is a change in velocity and t2 minus t1 is the time period. So this v2 minus v1 is the change in the y-axis. Change in y-axis by change t2 minus t1 is along the x-axis, change in the x-axis, which is equal to delta y by delta x. That is nothing but the slope of the velocity time graph. So acceleration can be calculated by finding the slope of the velocity time graph. Acceleration can be calculated by finding the slope of the velocity time graph. Case 4. Body moving with uniform retardation. We will plot the velocity time graph of a body moving with uniform retardation. Here, for 0 seconds, the velocity is 50 meter per second. For 5 seconds, the velocity is 40 meter per second, and 10 seconds it is 30 meter per second, and for 15 seconds it is 20 meter per second, and for 20 seconds the velocity is 10 meter per second, and for 20 seconds the object has come to rest. The shape of the velocity time graph with uniform retardation will be a straight line having a negative slope. Case 5. Body moving with non-uniform acceleration. We will plot the graph from the information that is given in the table. For 0 seconds, the velocity is 20 meter per second. For 5 seconds, the velocity is 30 meter per second. For 10 seconds, it is 40 meter per second. For 15 seconds, the velocity is 10 meter per second. And for 20 seconds, the velocity is 30 meter per second. For 25 seconds, the velocity is 15 meter per second. So there will be an irregular shape of the graph, which will be a zigzag line for a body moving with non-uniform acceleration. Nature of the graph of a body in non-uniform motion. A body in non-uniform motion, the graph will be a zigzag line.